Okay, continuing then. Question 5. Okay, question 5. I think I just wanted to show you a little trick because I can't remember who it was, but someone did a really good job of this question. So we're probably going to have to work through it to get to that point. So part A, find the amount they will pay the bank each month. Just bear with me a minute, sorry. You might want to skip through some of this. Okay, so they have 30 years and it's monthly, so 30 times 12. It's 3.8, yes. They need a loan for $170,000, we've got that. You can see I was partway through here. Okay, the future value is 0. The payment then is $792.13. So 792.13, and we're doing Australian dollars. Okay, if you want to show workings out, what we should be doing is writing down our values. It's kind of a bit tedious, like it's quite slow and you're just copying down loads of values, but it's the only way to get some workings. And I think if you look at the mark scheme, if you had 3 of these written down correctly, you got a method mark. So payment per year is 12, compounds per year is 12, and the future value is 0. Okay, part B, find the amount Raoul and Rosie will still owe the bank at the end of the first 10 years. So now, lots of us were doing this, 10 times 12 years. They borrowed 170,000. That's their payment. We want to find out how much is left. So we get this. So they still owe 133,020.30. Right, folks, just quickly while we're doing this is finance. So this is the only time we don't round to 3 significant figures in our course. With finance, we round to 2 decimal places because that's how money works. So we always give the full amount rounded to 2 decimal places. All other times, you need to be rounding to 3 significant figures in maths. Okay, part B2. This was the bit that had the most marks attached to it. I think it might have been worth 4 marks. Using your answers to part A and B1, calculate how much interest they will have paid in total during the first 10 years. Now, this is what one person did. They said, we've got to 10 years already. There's been 120 payments so far. They made the group size 120. So there's just one group. And then they pressed amort, which is down the bottom of your screen, kind of in towards the middle. And then here they said, right, that's how much to be paid back. Looks kind of close. That is the amount of interest I've paid. And they got it like that. So that's really nice. That's playing with the group size can be quite useful. Sometimes we set the group size as 1, which means that we kind of get a year by year. And I think somebody else might have done this. They might have done something like this and then copied this whole column into stats and then summed it, which was another good idea. It's a much more simplistic way of trying to solve this problem than the mark scheme does. And I think if you can find a simple way, a lazy way, it's always good in maths. If we make the group size 12, we're looking at every year. Still got to add all of those up. So this person, they said, well, let's make the calculator add it all up for me. So well done if that was you. Nice idea. Okay, question 6. This is one we're going to do again, and then I'm probably going to skip the next few because there wasn't really much to say. Question 6, I'm afraid, was done really badly, and I'm kind of a bit disappointed because it's all in the formula guide. So we've got an infinite geometric series. As soon as I read those words, I should be thinking about my formula. Sequence and series, that's topic 1. Okay, we've got geometric series, but it's an infinite one, so we need to look in the HL only section. There we go. So sum to infinity is u1 over 1 minus r. Let's write that down. Sum to infinity equals u1 over 1 minus r. Right. It's such that u1 equals 2. Oh, well, that's good. So we know what that is. And what does this say? It means add up from 1 to infinity all of our terms equals 10. So the sum to infinity is equal to 10. So what we can do is we can say, well, S infinity is 10, U1 is 2, and there we go. We've put the information from that first sentence into an equation. Part A says find the common ratio R for the sequence. Well, looking at that equation that all I've done is taken the information they gave in the question, found the relative part in the formula guide, and then substituted the values in that I've got. There is a bit of interpreting what that notation is saying, I suppose. But that's all I've done so far. We want to find R. We just solve this for R. 1 minus R equals 2 over 10. So 1 minus 2 over 10 equals R. R is 0.8. Find the least value of n. So that was part A. Part B. Find the least value of n such that un is less than a half. Okay, let's go back to our formula guides. We want a formula for un, and it was a geometric sequence. So nth term of a geometric sequence is this one here, u1 times r to the n minus 1. u1 times r to the n minus 1. u1 times r n minus 1. Find the least value of n such that that term is less than a half. Right, we want this to be less than a half. So u1 times r to the n minus 1 is less than a half. But I know some of these values. I know u1 is 2, I think. Yes, that was up here. u1 is 2, r is 0.8, n minus 1 is less than a half. I think we could probably use the function app to solve that. Just remember, we're talking n represents the figure number in your sequence, so it's got to be a whole number. It's got to be an integer, to use the word that we used earlier. So when we solve that, we're going to have to think about how we round. Do we round up or do we round down? Quite a nice way of doing this would actually be to put the left-hand side as a function. In fact, let's do it. Let's put it in as a function. 2 times 0.8 to the power of n minus 1. And then go to the table. Whoa, it's a bit too far down. Okay. So there's my first term, 2, and then we're timesing by 0.8. Okay, this looks right. And then I can just scroll down and I can find, oh look, there. That's the first time it goes less than a half. So n minus 1, hang on, when x is 8. Okay, so when x is 8, we get our solution. And we can just, maybe we can write that down. 2 times 0.8, 8 minus 1 is equal to 0.419, 0.419 dot dot dot. So that's one way of solving that one. Right, we are going to skip quite a few. We're going to, I don't really think there's an awful lot that I want to talk about in question 7. That was generally done pretty well. Question 8 was done pretty well. Some very interesting looking graphs, but generally they were close enough that I could give you the marks. Question 9 was done fairly well. Yeah, I think reacquaint yourselves with how to set up those matrices for the Markov chains. That transition matrix, but was done pretty well. Question 10, I think, yeah, it's one that you can work through with the mark scheme. I don't think we need to look at in class. But question 11, right. So this is clearly a trig question, and it's clearly in degrees because we're given this value. We're told that farmer Nate has 7 meters of fencing to make a triangle enclosure for his sheep. One end of the fence is positioned at point B on L2, so that is one end of the fence. 10 meters from A. The other end of the fence will be positioned at some point C on L1 as shown in the diagram. He wants the enclosure to take up as little of the current field as possible. Find the minimum possible area of the triangular enclosure. Right, this is a strange way of asking this question. Find the minimum possible area of the triangular enclosure. Why is it the minimum possible area and not just find the area of the triangle enclosure? If it's the minimum possible area, there must be more than one option, and one of them must be smaller than the other. Otherwise, there's no reason to ask you for that. It would just be find the area. It would be misleading otherwise. So this is a clue. There are at least 2 different sized triangles. And if there's 2 different sized triangles, we should be thinking about the ambiguous case. So, when we read these questions, I know you're working under a time pressure, but you really have to look out for those clues. In fact, I'll leave that underlined. We really have to do our best to look out for clues. So, we need to be thinking about this could be an ambiguous case. There's probably 2 ways of drawing this. Maybe there's another way like this, where this is also 10, where these are both 10. No, sorry, they're not 10, they're 7. And we're going to have to figure out which one we're getting. Okay, I think maybe we do this question. So we need, if we're going to find the area of this triangle, at some point we're going to need this length. Or we're going to need this angle, because we're going to use that formula, area equals half AB sine C. So I've got 2 lengths, I've got 7 and 10, but I don't have the angle between them. I've got the 40 degrees, but I don't have the 2 sides. I don't have both the sides, either side of it. So I'm going to have to find one of those 2 things. It doesn't really matter which one you do. I think because I've got I know these are opposite one another. I find the sine law easier. I find it quicker than the cosine law. So I think I'm going to do the sine law, and I'm going to find this angle C. And then if I know 2 angles in the triangle, I can find the 3rd one. So let's start with that. We're finding an angle. So if you need to, check your formula guide. Sine 40 over 7 equals sine C over 10. So calculated to find C, we're in degrees. I'm going to do 10 times sine 40. 10 times sine 40 divided by 7. So that is the sine of my angle. Sine C is that. Let's do the inverse sine of it. 66.67. 674, I think, came next. Degrees. Right, let's look at my diagram. I did this kind of rough sketch. I'm going to have one acute, this is possible C, and this is a possible C. One of them is acute and one of them is obtuse. And looking at the 2, the one that's further along L1 is going to be my acute one. So less than 90 degrees. This one has got to be obtuse, more than 90 degrees. And so this one has got to be the 66.674 degrees. And that is clearly a bigger triangle than if I use C2. That's less area. I'm getting all this extra area here. So I need to find this angle. All I do is subtract it from 180 because this is isosceles. This is also 66.674. And the one I'm after is on a straight line with it. So 180 minus 66.674. Let's be lazy and do that the easy way. 113.3. 3, 2, 6 roughly. I'm not rounding because it's not the end of the question. Right, that is definitely the angle I want. Sorry, the triangle I want. I don't want this one anymore. Okay, so that one is 113.326. I can now find angle B. The 3 of them add up to 180, so I can find that one. And then I am almost home and dry. Half AB sine C, I'm going to do a half times 7 times 10 times the sine of b. I'll let you finish that one off. As I said before, try and notice those clues. They spend a lot of time working on the language of questions, trying to make them not misleading, trying to make them accessible to everyone. So as soon as there's something that's quite clunky about the way something's written, it's probably a clue. Okay, I'm going to stop this video. I'm going to start another one to go through the last few questions.